Today we're going to talk about quadrilaterals. It's sometimes called quadrangles or even tetragons to be consistent with names like pentagon or hexagon. If you're lazy like me, photogons. So it's a four-sided polygon with four internal angles with four vertices or corners. And in order to classify them, we need to know their attributes. So what are some of these attributes? Can you think of any attributes on your own? Now, before talking about some of its attributes, I want to start with giving names to some of the sides. Because we have four sides and four angles to think about, unlike in triangle, the ordering will matter in this case. For example, if you say something like two sides are congruent, you have to specify which two are congruent. So here's a bit of a convention. For sides and angle, when you have a figure like this, when you see two sides not meeting each other, we just call them opposite sides. When two of the sides meet at a common vertex, we call them adjacent sides, or sometimes touching sides. Something similar can be done for angles. If you have two angles facing each other, but not sharing any sides, we call them opposite angles. So with that in mind, let's talk about some attributes. So here's a list of attributes that we can think of for given quadrilaterals. For one, we can talk about angles. So we can have a right angle, acute angle, obtuse angle, just like what we did with triangles. We can also talk about having congruent sides and angles. So you can have congruent opposite angles. You can have congruent adjacent sides. You can have congruent opposite sides, and so on. We can also talk about having parallel sides. Remember, sides should not meet if they're parallel. So parallel sides only occur with opposite sides. And we can count the number of pairs of parallel sides. Maybe you have none, or maybe you have one or two. We can also talk about some symmetry. For example, we can have line of symmetry, or we can also have a rotational symmetry. And finally, something special to quadrilateral, unlike triangles, we can also talk about convexity. These are some of the attributes we'll be using when classifying quadrilaterals. So for example, if you have a figure like this, something that looks like an arrowhead, you can see that it has two pairs of congruent adjacent sides. And you can also see that it is concave because the bottom two sides are going in and then leaving the place. You can also think of it as having internal angle being more than 180 degrees. And this is called concave kite. So before doing some of the problems, I'm going to give you some textbook definition of the figures that we'll be seeing. Now, this is a mere suggestion, and there are multiple ways to define shapes. Just use these as a reference. So a kite is a quadrilateral with two pairs of adjacent congruent sides. A parallelogram is a quadrilateral with two pairs of parallel lines. A trapezoid is a quadrilateral with one pair of parallel sides, which would look like this. Now, I do have a comment on trapezoids. With this definition, it's not clear whether we're talking about exactly one pair or at least one pair. It really depends on who you ask. Now, at least for this course, we will stick to having exactly one pair of parallel sides. Now, as a special case, if you have non-parallel opposite sides are congruent, it's called isosceles trapezoid. Now let's continue, and you have a rhombus. A rhombus is a quadrilateral with 4 equal sides. A rectangle is a quadrilateral whose 4 angles are right angles. And finally, a square is a quadrilateral with 4 equal sides whose internal angles are right angles, just like rectangles. So with the textbook definition as a reference, let's take a look at this problem here. So I'm given a word box that contains several different quadrilateral types. And for each letter shape that I'll give you, use the word to list all of the names that you think describe the shape. So let's look at the first shape. Figure A, that is a square. But we should also ask, is this a kite? Is this an isosceles trapezoid? Is this a parallelogram? Take a moment and think about whether these names apply to this figure here. So as I said, it is a square, but since we have 4 equal sides, this is also a rhombus. Since all of its internal angles are 90 degrees, it is a rectangle. You can see this figure having 2 pairs of parallel sides. So this is a parallelogram. This is also a kite because you see 2 pairs of congruent adjacent sides. And finally, this is a quadrilateral. Now this square is not a trapezoid because remember, in this course we agreed that a trapezoid should have exactly 1 pair of parallel sides. Since a square has 2 pairs of parallel sides, we're not going to call a square a trapezoid. Let's look at figure B. Well, figure B has 1 pair of parallel sides. So this is a trapezoid and a quadrilateral. You can also observe from the picture that 2 non-parallel sides are congruent. So this also turns out to be an isosceles trapezoid. Now take a look at C. Let's test some of the criterion or attributes. Does it have 4 equal sides? Does it have the right angles? Does it have parallel sides? Going through some of the tests, we can see that this is a quadrilateral because it's 4-sided, but none of the names apply here. With D, it can be thought as a rhombus, but since it has 2 pairs of congruent adjacent sides, it's a kite. The way it looks is that you have 2 pairs of parallel sides, so this is a parallelogram. And finally, it is a quadrilateral. We can go through many figures. E is a kite and a quadrilateral. F is a rectangle, which is also a parallelogram and a quadrilateral. G is a parallelogram and a quadrilateral. And H is a trapezoid and a quadrilateral. And sometimes H is called right trapezoid because it has right angles on 2 of the angles on your right. Now let's look at the second problem. So just focusing on 4 of the shapes, A, D, and F, G from the previous problem, we're going to try to find all of the attributes that each figure has and try to come up with our own definition. So what are some of the attributes can you find from A? What are some of the attributes you can find from D? Now this is not an exhaustive list. You can find more symmetries and more attributes in these figures. But here's a list of attributes you can find. So for A, you can find it has 4 right angles making it a rectangle. It has 4 congruent sides, making it a rhombus. It is opposite sides parallel, so making it a parallelogram. And something special to a square, it has 4 lines of symmetry. What about D? Well, you can see it has 4 congruent sides, making it a rhombus. It has opposite sides being parallel. Not only that, it has 2 pairs of parallel sides, making it a parallelogram. Opposite angles are congruent. And you can also see the 2 lines of symmetry for a rhombus. For F, well, it has 4 right angles. You can see opposite sides are parallel, making it a parallelogram. You can also observe that the opposite sides are congruent, also a property of a parallelogram, and 2 lines of symmetry. Finally, for G, we can observe that it has opposite sides being parallel. You have 2 pairs of parallel sides. You can see that opposite sides are congruent. You can see that opposite angles are congruent. And this has no line of symmetry. With attributes we just discovered, let's come up with different definitions for figures and quadrilateral types we just saw. Remember, these are the definitions we used. Now instead, what if I define rhombus as a parallelogram with congruent adjacent sides? Or a parallelogram as a quadrilateral with 2 pairs of congruent opposite angles? Or what if I define a rectangle in this way and a square this way? Now, there's nothing wrong with these definitions on their own. Mathematically speaking, they're equivalent, but often we prefer one over the other because it is easier to communicate and teach. For a rectangle, defining that as having all congruent angle, and knowing that means they're all right angle, we'll need to teach them that the sum of internal angles is 360 degrees. Now for a square, defining using lines of symmetry will be very hard unless the student is proficient in symmetry. Now, quick comment, as for parallelograms, I've seen both definitions in a book, and since we start teaching about parallel lines and congruent angles around the same time, they're used interchangeably. So let's summarize what we just talked about. So we talked about some of the attributes of a quadrilateral, like having a right angle, congruent sides and angles, parallel sides, symmetry, and convexity. Using these attributes, we defined what it means to be a square, rhombus, rectangle, parallelogram, a kite, a trapezoid. And at the end, I pointed out that you can define things differently, but one definition may be preferable to the other. So next time, we'll talk about how these types are related to each other. Thank you for watching, and I'll see you next time.